Implicit differentiation. Apa itu implicit differentiation? An equation that can be written in the form y equal to fx is said to define y explicitly as a function of x. For example, y equal to x power 5 plus x minus 3, y equal to third x minus 2x plus 2 over x. Here, y appear alone on one side of the equation. We call a explicitity. If y is not alone on one side of the equation, we say that the equation defines y implicitly as a function of x. For example, xy minus y square equal to 3 minus x. Some of the implicit function can easily be changed to explicit function. Some others implicit function will give more than one explicit function. Sometimes it's very difficult or impossible to change an implicit function to the explicit function. To differentiate an implicit function, we use first differentiate y respect to x, we write as dy dx. Number 2, differentiate y power of n equal to n y power of n minus 1 dy dx. So, kita buktikan number 2. Okay, kita let f in term of y, fy equal to y power of n. So, df dy equal to n y power of n minus 1. So, if you differentiate respect to x, so df dx equal to df dy times dy dx. Okay, kita guna change rule. So, if you cancel dy you get df dx. So, this is equal to df dy equal to n y n minus 1 dy dx. Here we get this. Okay, example 1, differentiate y square plus 4x equal to 6x square. Implicitly, we differentiate every term respect to x. Differentiate y square respect to x, we get 2y dy dx. Differentiate 4x respect to x, we get 4 equal to 12x. So 2y dy dx equal to 12 minus 4. So dy dx equal to 12x minus 4 over 2y. So we can simplify, we get dy dx equal to cx minus 2 over y. Number 2a, also we differentiate every term respect to x. Differentiate x squared respect to x, we get 2x. Differentiate y squared respect to x, 2y dy dx. 16, you get 0 here. So 2y dy dx equal to negative 2x. So now dy dx equal to negative x over y. Dx times y cubed minus y squared equal to 3x power 4. Find dy dx. So we differentiate every terms respect to x. Now look at here, this is a product, x times y cube. So this is a product. So we use a product rule. So remain x differentiate y cube respect to x plus remain y cube differentiate x. This is a product rule. Minus differentiate y square respect to x, and then differentiate 3x power 4 respect to x. So x differentiate y power of 3 get a 3y square divided x plus y cube differentiate x respect to x get 1 minus differentiate y square respect to x, we get a 2y dy dx equal to 12x cube. So we have two terms dy dx here and here. So we factorize dy dx 3xy square minus 2y equal to 12x cube minus y cube. Therefore, dy dx equal to 12x cube minus y cube over 3xy square minus 2y. Okay, C, find dy dx in terms of x and y. X squared over 1 plus y squared equal to 4x minus 2. So we differentiate every term respect to x. And then this is you use a quotient rule. Use a quotient rule here. V times u prime minus u times v prime over v square. So this is v times u prime dapat 2x minus ux square. This is differentiate 1 plus y square 1 plus y square to 2y divided x over 1 plus y square, and then you square again equal to 4, and then you cross product here, and then we simplify x square times 2y divided x equal to 1 plus y square times 2x minus 4 times 1 plus y square, and then you square again. The right hand side here we can factorize 1 plus y square, and then we can simplify as the final solution here. Example 3, given that the equation of the curve is 3x squared plus 4y squared equal to 15xy minus 6. Find the value of dy dx and the second derivative at a point 1, 3. First of all, we differentiate every term respect to x. Differentiate every term respect to x. And then you look at here, this is a single variable, this is a single variable y, this is a products x and y. It's a product rule. So we use a product rule here. So differentiate the 3x squares, you get a 6x plus 8y dy dx equal to 15x differentiate y, and then plus remain y differentiate 15x, and then differentiate 6 equal to 0. So 6x plus 8y dy dx equal to 15x dy dx plus 15y. So 8y minus 15x times dy dx, because we have a two terms contain dy dx here, so equal to 15y minus 6x. At a point 1, 3, we substitute x equal 1, y equal 3 into this equation. And now we get a dy dx equal to 13 over 3. So next, to find the second derivative, we differentiate this equation again. So 8y minus 15x dy dx equal to 15y minus 6x. And then this is a product rule. U equal to 8y minus 15x. And then this is a v, this is a v dy dx. So we use a product rule, remain 8y minus 15x, differentiate dy dx again, plus remain dy dx, and then differentiate 8y minus 15x equal to differentiate 15y respect to x and differentiate 6x respect to x. So now here we get 8y minus 15x, differentiate dy dx again, we get a second derivative, plus dy dx, differentiate 8y, we get 8 dy dx, minus differentiate 15x, we get a 15 equal to 15y dy dx, differentiate 6x, we get a 6. So we simplify 8y minus 15x times this second derivative plus 8 is a 8 dy dx times dy dx, that means dy dx square, first derivative square, minus dy dx times 15, you get negative 15 dy dx equal to 15 dy dx minus 6. Next, 8y minus 15x times second derivative plus 8 the first derivative square minus 30 dy dx. This is negative 15 dy dx. This is negative if you bring to the left hand side, 15 dy dx. So we get a negative 30 dy dx. And then minus 6 here, that means plus 6 equal to 0. So at the point 1, 3, we substitute x equal 1, y equal 3. Now we get 9, the second derivative plus 8 times 13 over 3. This is a dy dx from the previous solution. Square minus 30 times dy dx equal to 13 over 3 plus 6. And then the final solution, the second derivative equal to negative 236 over 81. Question number 4. If x squared over 15 plus y squared over 9 equal to 1, show that 5y, the second derivative, plus 5 times the first derivative square plus 3 equal to 0. So we find the first derivative. We differentiate every term respect to x. We get a 2x over 15 plus 2y over 9 dy dx equal to 0. And then we differentiate again. Differentiate 2x over 15 respect to x plus differentiate 2y over 9 dy dx. This is a use a product rule here. Products. This is a product. U, this is a u, and then this is a v. As a v. So we get an answer 2 over 15 plus 2y over 9 differentiate again dy dx plus remain dy dx differentiate 2y over 9 respect to x equal to 0. It's a product rule. 2 over 15 plus 2y over 9. This is we get a second derivative. This is a second derivative. Dy dx. Differentiate 2y over 9. We get 2 over 9 dy dx. So 2 over 15 plus 2y over 9 is a first derivative. And then 2 over 9 is first derivative square. First derivative square here. Okay, to prove that, you get a 5, we time every term with 45 over 2 we time every term with 45 over 2, and then the left hand side and the right hand side with 45 over 2. After we simplify, we will get a 3 plus 5y second derivative plus 5 the first derivative square equal to 0. So we arrange 5y the second derivative plus 5 the first derivative square plus 3. So shown.